By using the substitution u is secant x, or otherwise find an expression for a given integral in terms of n, where n is a non-zero real number. When we use the substitution, an idea is the next. We need get an integral in terms of u only, so that it can be integrated without a calculator. So if u is secant x, the next step is, as usual, we need to find derivative du dx. Formula is given in a data booklet. Derivative of secant is secant tangent, and then we solve this for dx, and dx it's du over secant tangent. Also we need limits in terms of u, so the lower limit it's secant of 0, it's 1 over cosine of 0, it's 1. u2 it's secant of pi over 3, it's 1 over cosine of pi over 3, cosine of pi over 3 it's a half, so it's 1 over half, it's 2, and hence a given integral becomes integral from 1 to 2, secant to the power of n becomes u to the power of n tangent, and dx is du over secant tangent. Secant is u and tangent, and we can see the tangent cancels and we get integral in terms of u only as required. If some function cannot be easily replaced by something in terms of u, we don't hurry up, because it may be cancelled like here. So we get integral from 1 to 2. We can divide u to the power n by u and get u to the power n minus 1 du. And it's a usual function like x to the power of n, which can be easily integrated, and it becomes u to the power n minus 1 plus 1, which is u to the power n, and divided by n, and limits from 1 to 2. And substitute the upper limit for u, so it becomes 2 to the power of n over n minus 1 to the power of n over n, and it is equal to 2 to the power n minus 1 over n. Or it is possible use limits in terms of x, but we don't find the limits in terms of u, but here we can write that there are some limits in terms of u, u1, u2, and the same integral, and when we integrate it, it becomes u to the power n over n, and we can write again u in terms of x, secant x to the power of n over n, and write limits in terms of x, so to write 0 and pi over 3, and calculate, substitute the upper limit minus substitute the lower limit, and get the same result. And that's all for this question.